Hello, we're looking at pure 1.3 factorizing. So in your notes we're going to be looking at the skill of putting in one set of brackets. So this is the standard factorizing you'll know from GCSE, where you find the highest common factor of the two terms that you are factorizing. In this case 6x and 21. I like the Venn diagram method, so I put in my factors of each into the Venn diagram, my prime factors, and the middle number is the highest common factor, and in fact if you multiply the other terms you get 2x and 7, and that's how you find the inside of the brackets quite neatly. If we do it on something more complicated, its value takes on, is much clearer. So we draw our Venn diagram. Common factor of 6 and 8 is 2, and 3 and 4 are what's left over. And if we do that with x's as well, one x goes in the middle, one to the left hand side and none to the right. And the y's, 3 of the y's in the middle, so y cubed, and y to the 4 is left over here. If we multiply everything in the middle section, the intersection, we get the highest common factor, and that's what we write at the start. If we multiply the other two terms, 3 times x gives us 3x, and 4 times y to the power 4 gives us 4y to the power 4. Remembering, of course, to keep the same sign in between those two terms. Okay, the next skill is putting in two sets of brackets using dots. We're still doing pure 1.3 factorizing. So dots, of course, stands for difference of two squares. There's an equation we can use to remember it, and it's appearing on the screen. We can hear this verbally as well as the difference of two squares, which is what you see on the left-hand side, is equal to the product, which is what you get when you multiply two things, of their sum and their difference. So if we do that on paper, we are trying to see the two things that we're squaring. So I like to put in brackets like this, and it makes it very simple from then on. Again, the value is more apparent in something more difficult. We're square rooting each of the factors and putting them in the brackets. Square root of 9 is 3, square root of y squared is just y, and the square root of a to the power 4 is a to the power 2. Now that we can see the two things that we've squared, we can add them and subtract them really easily and just throw them into brackets. Okay, here's the big one, Factorizing Quadratics. Pause quickly so you can copy down the skill. We're going to zoom into example 1, hopefully very soon. Oh, here we go. There we go. Now, if we remember, the coefficients of x squared, x and 1, x squared, x and 1, are the letters A, B and C. So these numbers in front, these letters, they're called those numbers called coefficients. And we just label the numbers out because they're important. The sum number is that middle one. That's the thing we're going to add up to. And the product number is this one on the end, C. So what we do in practice is we list out the pairs of numbers that multiply to make our product number. Now one of them has to be negative and one positive because our product number is negative. So we're just listing through these and we're seeing what they add up to. Now positive 12 minus 1 don't make plus 4, but positive 6 and minus 2 add up to make positive 4, so they're the correct numbers. And now all we do is place our two numbers inside the brackets. Okay, then we're off to have a look at example 2. Copy this down, and you will notice immediately that Mr. 24 at the front here is causing us an issue. So because of that 24, we have to do a slightly different method. And that method entails multiplying 24 by our product number, which is 2. So our product number is going to increase And we go through the same method, finding factors of 48. Remembering, of course, that if they're multiplying to make a positive number and they add to make a negative, they're both going to be negative. There's no other way of doing it. You would reach that conclusion quite quickly, but just to explain why I'm only looking at negative numbers. So we arrive at them with -3 and -16. Now here is the new part of the method. We're going to write the A number, 24, 3 times, as you see on the screen, in front of the letter, in this case Y. Inside brackets at the top, and at the bottom you've just got this denominator. Now at the top it just looks like standard factorization, and we're just plonking our numbers inside the brackets as before, so nice and simple so far. Next, we have to factorize the top 2 brackets, so the actual thing inside the bracket gets factorized. 3 comes out of the first bracket, and an 8 comes out of the second bracket. We still have the denominator of 24. And we cancel it with the 8, leaving 3 in the denominator. But that cancels with the 3. So we're left with no denominator, and all we have left are 2 brackets, and we're finished. And that's a valid method for factorization, always. It will always work for factorization. So since I know many of you will use a different method to do this, I thought we would run through what method you probably would use. So you would take -3 and -16 and you would split that middle term into those 2 numbers. And you would factorize the first pair of numbers. But the thing that I want to explain to you and perhaps even convince you why I like the other method better is that minus there is always tricky to deal with when you're factorizing these 2 terms, because we need to change the sign of this, whatever it is. So now that there's a negative there. And even worse, when that number's just a minus, you can't see the 1 that is hidden as a hidden factor, which appears in your first bracket. So that is a valid way of doing it. It gives you the same answer as you can see. And in fact, many of the steps are mathematically the same. If you kind of actually go through the method of it, it is the same idea, but I prefer my way of doing it. So I'm just going to kind of let you know that. I do want to show you another method as well. Okay, so this is a method a lot of you are fond of. It's called just guessing it, figuring it out, trial and error, whatever you want to call it. You'll start by listing out the number of kind of ways that you can make that 24y squared. Now, I've deliberately chosen 24 because I know it's got masses of numbers of pairs of factors. There's lots of them. In fact, there's 4 combinations that we could use. And now you've got to go through. It happens to be the 3rd one in the list, but you don't know that to begin with. So you could start and do loads and loads and loads of work, waste loads and loads and loads of time, compared to a more easy style question where you've got just a single prime number, which can only be factorized in 2 ways. Just worth pointing out that sometimes, and at a higher level, giving you a nasty number for A can be a deliberate attempt to undermine this method. Be aware of that, and learning and being able to use another method is always handy, and falling back when you see a nice number like 3 or a 7 or a 5, you can fall back on the old method.